This is a video review titled Digital Apocalypses and Artificial Alchemies, Language in the Age of its Technical Reproducibility by Enrico de Santis. It's a really fascinating piece that digs into how modern AI is fundamentally rewiring our entire relationship with language.
We're talking about artificial intelligence. Today, we're going to look past all the headlines, past the hype, and really dig into the philosophical bedrock and the mind-bending mechanics behind these machines that are literally learning how to think. So let's pull back that curtain.
And we're going to start with this quote from the philosopher Emanuele Severino, because it just cuts right to the chase, doesn't it? It frames the whole conversation perfectly. See, we're not just talking about fancier calculators or robots on an assembly line. The real ambition here, or, maybe the real fear, is whether a machine can step into our world, the world of poetry, of philosophy, of prayer, and not just participate, but do it better than us.
And really, it all boils down to this one simple, almost childlike question that has been the engine behind AI research for decades. Is there a ghost in the machine? A spirit? A consciousness? That sense of wonder, and maybe a little bit of fear, is what drives everything we're about to explore.
Okay, so to really get our heads around AI, we have to take a step back and talk about something much more fundamental, the idea of technique. Now, technique isn't the technology itself. It's not the hammer, it's the idea to hit the nail. It's that deep, fundamental human drive to look at a problem and ask, how can I make this easier? How can I automate this? It's a way of thinking that existed long before the first computer.
So if technique is that basic human impulse to automate things, then artificial intelligence, well, that's its final, ultimate form. Think about it. We've spent centuries automating physical work, automating the farm, automating the factory. Now we've arrived at the final frontier, the automation of thinking itself.
Now, this journey has had two really different chapters. First, you had classical AI, which was all about rules, logic. Think of an old-school chess program where a developer had to painstakingly write code for every possible move, every single strategy. But modern AI, it's a completely different beast. It doesn't follow rules, it learns them. You don't tell it what a cat is, you just show it a million pictures of cats, and it figures out the pattern on its own.
So what does that learning actually look like under the hood? You can basically break it down into a three-step dance. First, representation. You take something from the real world, like an image or an article, and you turn it into pure numbers, into math. Then comes the training. This is where the model just plows through mountains of that data, finding patterns through endless trial and error. And finally, you get inference. The now trained model can look at brand new data it's never seen before and make a really good guess, or a prediction about what it is.
Okay, now this is the secret sauce.
This simple idea is the engine that makes things like ChatGPT work. It's a concept called the distributional hypothesis. Basically, the AI doesn't know what the word cat means in some deep philosophical way. It just knows that the word cat shows up really, really often next to words like purr, meow, kitten, and fur.
And this new approach? It's all built on this incredible idea called semantic holism. So what's that? Well, it just means that a word doesn't really have its meaning in a vacuum. Think about the word bank. It means one thing if you say riverbank, and something totally different if you say investment bank. The meaning actually comes from the context, from all the other words around it. And that was a massive leap forward from just trying to teach a machine a dictionary.
Which, leads us to the billion-dollar question. If meaning is all about the context, how in the world do you get a machine to actually understand that? How did we make the jump from rigid, rule-based systems to something that seems to navigate the messy, beautiful, fluid thing that is human language?
The core idea here sounds almost too simple. You take a giant neural network, you show it a sentence like, the cat sat on the, and you train it to do just one thing. Guess the next word. It guesses, you tell it if it's right or wrong, and it tweaks its own wiring to get a little bit better. Now, here's the wild part. You don't just do this a few times. You do it billions, maybe even trillions of times, with huge chunks of text from the internet. And by getting really, really good at that one simple task, the AI basically teaches itself grammar, facts, context, and even style. And this whole process got a massive rocket booster in 2017 with a new kind of architecture called the transformer. The secret sauce was this powerful new tool called an attention mechanism. And for the very first time, this let the model look at a whole sentence or even a whole paragraph and figure out which specific words were the most important for predicting the next one, even if those words were far apart.
And this is where things get truly mind-bending. This attention feature operates inside something called a context window. For a state-of-the-art model like GPT-4, that window can be up to 96,000 words long. Just let that sink in for a second. For every single word it generates, it is actively considering a chunk of text the size of a novel. Santis calls this its cognitive field. It's the entire world the AI is looking at when it thinks. So with that massive cognitive field, how many possible things could the AI create? What's the scale of its potential universe of meaning? Santis presents us with this number. That's 50,000, its rough vocabulary size, to the power of 96,000, the size of its context window. I mean, just look at that thing. It's not a billion, it's not a trillion. It's a number so outrageously large, it basically breaks the human brain. It's a number with more zeros than there are atoms in the known universe. This is the theoretical space of everything the AI could possibly say. So that number we just saw, the one that's basically impossible to comprehend, it actually has a name. It's called the potential semantic space. It's the total number of all possible meanings the model can generate. Now, of course, almost all of those combinations are just total gibberish. But hidden inside that near infinity is every coherent sentence, every beautiful poem, and every brilliant idea that the AI is capable of creating. It is quite literally its universe of potential thought. And this brings us to one of the most critical takeaways from all of this. For these huge AI models, the basic unit of meaning, the hero of the story, is no longer the single word. It's the entire context window. A word only gets its meaning from its relationship with the thousands of other words that happen to be surrounding it at that exact moment.
You know, it really makes you think of the philosopher Ludwig Wittgenstein, who famously said, "The limits of my language mean the limits of my world." By giving this machine a language that spans 96,000 words at a time, we haven't just made it a better pattern matcher. We have exponentially, almost infinitely, expanded the limits of its world. This incredible new capability forces us to go back and revisit all the classic philosophical debates about AI. The Turing test. You know, can a machine fool you into thinking it's human? It almost seems kind of quaint now. A lot of models can pass that test. The real debate, the one that's front and center today, is John Searle's Chinese room argument. Is the AI actually understanding language, or is it just an incredibly sophisticated machine that's manipulating symbols it doesn't really comprehend?
And here is where Santis makes his move. He argues that because these models aren't just following rules that we wrote for them, because they're actually building their own complex geometric maps of how language works, where similar concepts cluster together, they're doing something more than just manipulating symbols. They are, he suggests, emulating a form of understanding.
So where does all this go from here? Well, it seems we're entering a new phase of convergence, sometimes called Neurosymbolic AI. And it's basically a fusion of the two worlds we talked about at the beginning. It's about combining the creative, intuitive, pattern-matching power of modern AI with the strict, logical reasoning of classical AI. It's like taking a poet and a mathematician and getting them to work together inside a single, more powerful mind.
Which leaves us with this one last, pretty heavy thought from the philosopher Karl Jaspers. For so long, we've been the ones acting on technology, shaping it. But now, we have to face the reaction. As we build these new intelligences that mirror our own minds, how is this technology in turn rebuilding us? How is it modifying our very essence?
This content is part of Aeon Research Land,